1, 2, 3, let's get started. In section R.1, we're going to look at sets. A set is a collection of objects. For example, we have the set A here, which is equal to the numbers 1, 2, 3, 4. Now, when we talk about sets, we generally use these curly brackets or braces to denote a set. In this case, we have a set with the numbers 1, 2, 3, 4, so there are 4 elements in this set. We have another set, B, and this set will consist of the numbers 5, 6, and 7. In this set, we have just 3 elements. Now, there's also notation that we should be aware of. We can say in set A, 4 is an element of set A. We use this symbol here. It looks like a C with a line in the middle. So we can say 4 is an element of A. In set B, notice that it does not contain 4 as an element. So we can say 4 is not an element of B by putting a dash through the symbol for element. Let's consider another set. Let's look at the set of natural numbers. This is just the numbers 1, 2, 3, 4, and it continues counting upwards forever. This is the set of natural numbers. Now this set is infinite. It goes on forever, while set A and B are finite sets. They do not have infinite elements. Example 1, we want to identify each set as finite or infinite. Then determine whether 10 is an element of the set. In part A, we have the numbers 7, 8, 9, and it continues to count up to 14. This is clearly finite since there's only a set amount of elements. So we'll write down finite for part A. Part B, we have 1, 1/4, 1/16, 1/64th, and it continues on forever. There's going to be infinite elements in this set. We have a vertical bar. This is pronounced such that, and so we have x such that x is a fraction between 1 and 2. Now, how many fractions are there between 1 and 2? Well, there's going to be infinite fractions. We have 1 and 1/2, 1 and 1/3, 1 and 1/5, and it can go on forever. So this has infinite possible elements. So this has infinite elements. In part D, x such that x is a natural number between 9 and 11. Well, this set is going to be equivalent to 9, 10, 11. These are natural numbers, and so there's just 3 elements in this set. In part D, this is just a finite set. Now for the second part of the question, determine if 10 is an element of the set. In part A, 10 is going to be an element of the set because we're just counting 7, 8, 9. 10 is going to be in this set here. It's in between 9 and 14. In part B, we have fractions 1, 1/4, 1/16, 1/64, and it will continue to have fractions 1/128 and so on. So 10 is not an element of this set. In part C, x such that x is a fraction between 1 and 2. 10 is not going to be in this set because 10 is not a fraction. Ten is not a fraction between 1 and 2. In part D, we already know the set is just the numbers 9, 10, and 11, so 10 is an element of the set. Example 2. Use set notation and list all the elements of each set. X such that x is a natural number less than 5. So for part A, we're going to look at the numbers less than 5 that are natural. So the first natural number is 1, 2, 3, and 4. So these are all the numbers that are less than 5 that are natural numbers. Part B, x such that x is a natural number greater than 7 and less than 14. So we'll list the first number that's greater than 7. That's a natural number. That's 8, 9, 10, 11, 12, 13. We have to be less than 14, so we'll stop there. This is our set. We say the universal set contains all the elements of the set. When we're talking about the universal set, we use the symbol U so that readers know this is every single element in that universe or in that set. The null set is known as the empty set. We use this symbol, it's a circle with a dash through it, so it tells the reader the set contains no elements. Or we can use this symbol, which is just braces without anything inside. This is also the symbol for the null set or the empty set. We say that A is a subset of B using this symbol if every element of A is also an element of B. So for every value that's in this A, it's also in B. If I look at a diagram, the set A is completely contained in the set B. The set A is completely contained in the set B, so we say A is a subset of B. Now, a proper subset is different. A proper subset is A is contained in B, but A is not equal to B. For example, we have A is equal to the numbers 1, 2, 3, and B is equal to the number 1, 2, 3, 4. So A is a subset of B, and A is a proper subset of B because A is not equal to B. So when we use this symbol without the line underneath it, it means they cannot be equal, but A is contained in B. If we use the symbol with the line under it, A is contained in B, or A could possibly be equal to B. Example 3, let the universal set be 1, 3, 5, 7, 9, 11, 13. A is the numbers 1, 3, 5, 7, 9, 11, and B is 1, 3, 7, 9. C is 3, 9, 11, and D is the numbers just 1 and 9. Determine whether each statement is true or false. D is a subset of B. Set D, we have the numbers 1 and 9, and 1 and 9 also appear in set B. So yes, it is true that D is a subset of B. We have the numbers 1, 9 also appearing in set B. Part B, is B a subset of D? We'll have to look. We have 1 is in D, but 3 is not contained in set D. So D does not have a 3, a 7, so we know that B is not a subset of D. So part B is false. Part C, C is not a subset of A. We have the numbers in C as 3, 9, and 11. 3, 9, and 11 also appear in A. So this statement is false. It is that C is a subset of A. So this statement is false. Part D, the universal set is equal to A. if I look at the universal set, we have all of the numbers here except 13. 13 is not in the set A, so the universal set is not equal to A. This is a false statement. A complement is another fancy word for opposite. A complement is equal to the set X such that X is an element of the universe, but X is not an element of A. So let's consider our universal set U. We have A inside that set. A complement is everything that is in our universe but not in A. So it's the opposite. A is here, and outside of that is our complement, A complement. Sometimes we also pronounce this as A prime. Let the universal set be the numbers 1, 2, 3, 4, 5, 6, and 7. A is 1, 3, 5, 7, and B is 3, 4, 6. Find each set. For part A, we're looking for A prime. Now remember, A prime is everything in our universe except in A. So I'll look at our numbers 1, 3, 5, and 7. 1, 3, 5, and 7. These are all the numbers in A. So A prime would be things in the universe that's not in A, and that's 2, 4, and 6. Everything that is not in A is 2, 4, and 6. So A prime is 2, 4, and 6. Part B, we're looking for B prime. To find B prime, we'll look at the numbers 3, 4, and 6. And B prime, or the complement, is everything besides these numbers. I have 1, 2, 5, and 7. B prime is 1, 2, 5, and 7. Part C, the complement of the empty set. The complement of the empty set is going to be our universe. What's the opposite of emptiness? Well, it's everything in the universe. Part D, the complement of the universe. What is the opposite of all of the elements? Well, there's nothing else. So the complement of the universe is the empty set. The intersection is defined using this symbol. It looks like an upside down U here. A intersect B is equal to X such that X is an element of A and an element of B. So if we draw a Venn diagram of this, we have the universe. This is set A. This is set B. So for the intersection, we have that it must be an element of A and an element of B. So the intersection is the overlap between them. So it has to be in both A and B to be considered in the intersection. A disjoint set is when the intersection is empty. For example, we have A is equal to 1, 2, 3, 4. B is equal to 5, 6, 7. Here, A intersect B is going to be empty because there is no overlap. They don't have anything in common. This is known as a disjoint set when the intersection is empty. Example 5, find the intersection of two sets. Part A, we have 9, 15, 25, 36. 15, 20, 25, 30, and 35. To find the intersection, find what is in both. 9 is not in both. I have a 15 that is in both. I have a 25 that's in both. And 36 is not in both. So in part A, the intersection is just the numbers 15 and 25. That is what is in both. For part B, they share a 2, they share a 3, and they share a 4. The intersection is 2, 3, and 4. These numbers are in both of the sets. In part C, we have 1, 3, 5, 2, 4, 6. There's nothing in common. There's no elements that they both share. So the intersection is empty. This is a disjoint set. They have nothing in common. This is disjoint. Let's look at the definition of union. A union B is equal to X such that X is an element of A or X is an element of B. Notice we use the word or and not the word and. Let's consider a picture. We'll have the same situation where we have a universal set. Here is set A. Here is set B. Now it says X is an element of A, so all of A or all of B. When we use the word or, we mean it's in A, or it's in B, or it's in both. So both is included as well. Example 6, find the union of the two sets. Part A, we have the numbers 1, 2, 5, 9, 14. Union that with 1, 3, 4, 8. Now for a union of a set, it's actually pretty easy. We just list all of the elements. So we have a 1, 2, 3, 4. We have a 5, an 8, a 9, and 14. So for the union, we list all of the elements, 1, 2, 5, 9, 14. And in this case, we don't repeat ourselves. So we'll just write 1 once, 3 once, 4 once. And we'll list all of the elements for this set. In part B, again, we're just going to list all of the elements because for a union, you're in the first set or you're in the second set. So we'll just list them all. 1, 2, 3, 4, 5, 6, 7. For part C, we have the numbers 1, 3, 5, 7. So these are the odd numbers. 2, 4, 6, and so on. So these are the even numbers. So in this case, we have the set of numbers 1, 2, 3, 4, 5, 6, and it'll continue on forever. This looks like a familiar set. This is the set of natural numbers. So we'll use the symbol n. To do this question, I want to always try to do all of the complements first. So I'm going to focus on m complement or m prime. We have m prime is the numbers 1, 3, 5, 7, 9, 10, 11, 12, 13. And we're going to union that with Q, so let's write down the numbers. And in this case, set Q is 0, 2, 4, 6, 8, 10, 12. We'll have a parentheses around this, so we'll have to do the inside first. And then we're going to intersect that with set R, which is 0, 1, 2, 3, 4. Now the union, remember, is in one set or the other, so we're just going to make a list of the numbers. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Again, the union is just a list of all the elements in both of the sets. I'm going to intersect that with 0, 1, 2, 3, 4. For the intersection, we have to be in both, or it will not be included. So we have a 0 that's in both, a 1, a 2, a 3, and a 4. So our set is 0, 1, 2, 3, 4, or this is equivalent to the set R. In this example, I want to intersect Q complement with N complement intersect the universe. Again, I like to use the complements first, so let's find Q complement. Q complement is everything that is not in Q. So in our universe, we have Q is 0, 2, 4, 6, 8, 10, 12. So everything that's not in our universe. Q complement is everything that is not in Q. That would be 1, 3, 5, 7, 9, 11, 13. So let's list Q complement. Again, that's 1, 3, 5, 7, 9, 11, 13. Q complement is everything that is not in Q but in our universe. N complement is going to be everything that is not in N, but in our universe. We have N are the numbers 1, 3, 5, 7, 9, 11, 13. So the opposite of that would be 0, 2, 4, 6, 8, 10, 12. N complement is the opposite of N, so it's 0, 2, 4, 6, 8, 10, 12. Now I have everything that we need. Let's do the problem. Q complement is going to be the odds from 1 through 13. Q complement is the numbers 1, 3, 5, 7, 9, 11, 13. We're going to intersect that with N complement. That's the set 0, 2, 4, 6, 8, 10, 12. Intersect that again with the universe, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now we always start with the inside of the parentheses first. We have intersection. Remember, that has to be in both. So we're going to look at the numbers that's in both. 0 is in both. 2 is in both. 4 is in both. 6, 8, 10, and 12. Now we have the set 1, 3, 5, 7, 9, 11, 13 is going to intersect with 0, 2, 4, 6, 8, 10, 12. And now we can check the intersection between these two sets. And it appears that they have nothing in common, so the intersection between these two sets is empty. So now try your homework out, and if you have any questions, please send me an email.